In the last task, you learned how to convert raster data to the vector data model. It can also be very useful to have data represented as rasters. Rasters are very useful for analysis, for example. In the last lab, you saw how rasters can be combined via the raster calculator to create a site selection analysis. Whether your vector data are points, lines, or polygons, they can be converted to rasters. However, one must be cognizant of the effects of cell size. The data will be generalized when the conversion from precise vector locations to cells occurs. In this task, I'll convert a vector layer to a raster. Here I have QGIS Desktop version 2.4 open. I'll demonstrate how to convert the Nueces Roads vector dataset to a raster. So to accomplish this, I'll go to the raster menu, to conversion, rasterize. The input file is going to be Nueces Roads. Next, I can pick the attribute field that will be assigned as the output raster values. This can be any numeric attribute. Often it'll be a field that's assigned some sort of weight to the output raster cells, but here I'll simply use the ID column, TLID. Next, I'll press select to choose the output file, and I'll call this roads raster. .tiff, I'll make it a geotiff. If you get this message, the output file doesn't exist, that's fine, just click OK. For now, I'll just take the remaining defaults, and just as we did the raster to vector conversion, this is using a GUDL command, and so you're getting the command line equivalent of the GUI-based command that we're running. I'll click OK to run the tool. It takes a moment to process. When it's done, you'll get the processing complete. Click OK, OK, and close. So this is a pretty straightforward procedure. The resulting raster has values matching those TLID values for the road pixels and values of 0 for the remaining pixels. In this lab, you learned how to use the heat map plugin to generate point density rasters based off of both point densities and attribute values, in this case population. Density analyses are often used to analyze data related to crimes or the amount of fast food stores in an area. The output provides a nice overview of how close the points are, and you can choose your own variables to weight the output. Finally, using the conversion tools, we can convert between raster and vector. Having data in the raster form allows you to perform raster algebra operations via the raster calculator. Having data in the vector form allows for precise positioning, for geometries to be easily calculated, for example, acreage and distances, and for more sophisticated cartographic options using both the border and the fill.